Okay, hello, this is Mr. Weideman, and I'm helping you on your AP Physics UT Quest assignment on impulse and momentum. This is the attack helicopter problem, and this is a pretty cool problem, because it's a cool problem, and also because we have some two different physics concepts that are blended into this. So we have this helo firing a burst of bullets. That's actually its refueling boom, but I don't know. It looks like okay, whatever. Bullets coming out of its refueling boom. So what we have is these bullets. Then they have a change in momentum, and that needs a force. And the force that's applied to these bullets is going to be the recoil force on the helicopter. So we have an impulse and momentum, and we also have a third law problem. Okay, so let's look at the bullets first. Okay, so we're going to use the impulse takes a change in momentum. Okay, so we know that these bullets are changing velocity because they're being fired. It takes a force to do that. We could use Newton's second law and do all that stuff, but we know that impulse momentum theorem really is basically Newton's second law. All right, so let's just look at the bullets for now. All right, so let's do our impulse momentum. And what I'm going to say, the initial velocity of the bullets are 0. And I'm going to do that because let's just say I'm going to use the helicopter. It doesn't matter if it's moving forward, backwards, up, or down. All right, the bullets are riding in the helicopter, so relative to the helicopter, I can say their initial velocity is 0. And that's going to help us out a lot. All right, final velocity. That is the velocity that the bullets actually leave the muzzle, leave the helicopter. And again, I'm going to put that relative to the helo, so it makes my delta velocity of the bullets easy. Okay, now mass of the bullets. Now there's a couple of different ways to solve this problem, but I think this is the easiest, is I'm going to take the total number of bullets, which is given in the problem, and multiply the mass of each bullet. Make sure that you convert that into kilograms. Okay, and then the time that the burst is being fired is given. All right, so what this can do is this can tell me the average force that was required to fire this burst of bullets. Okay, so I can solve for F average. Now it becomes a Newton's third law problem. All right, so this recoil of the helo, okay, the machine gun pushes on the bullet, and then the machine gun then pushes on the helicopter. Right? It's part of that. It's attached to the helicopter. So now we have a third law problem. Okay, so now let's use impulse and momentum for the helicopter. And we want to find out, how much this recoil is going to change the velocity of the helicopter. So we're going to use this force of the bullets, and that is going to be an equal and opposite force on the helicopter. Okay, and so then we are then going to back calculate the change in velocity of the helicopter, and I think we're going to find the mass of the helicopter is such that its delta V is quite insignificant. And that's how you go about solving this problem. Again, kind of a neat problem. It blends impulse and momentum theorem and Newton's third law. All right, so good luck with this.